New suns and the mysteries of the universe. The universe is filled with wonders we are only beginning to understand. From the birth of new stars, often referred to as new suns, to the deepest mysteries of black holes and dark matter, the cosmos continues to challenge our knowledge. Stars are born in vast clouds of gas and dust, called nebulae. These clouds collapse under gravity, forming new suns in a process that can take millions of years. The birth of new suns. As the gas cloud collapses, the pressure and temperature rise, igniting nuclear fusion in the core. This marks the birth of a new star, or what we often call a new sun. But every star's journey is unique, and their life cycle can be just as mysterious as their origins. From small red dwarfs that burn for billions of years, to massive supergiants that end their lives in spectacular explosions known as supernovae, each star has its own story to tell. Mysteries of the universe. Yet, stars are only a small part of the mysteries the universe holds. Scientists have uncovered phenomena like dark matter, an invisible force making up most of the universe's mass, and dark energy, a force causing the universe to expand at an ever-accelerating rate. Black holes, regions of space where gravity is so strong that not even light can escape, continue to baffle astronomers. Could they be portals to other parts of the universe, or are they the final stages of some of the universe's most massive stars? What we don't know. Despite all we have learned, many questions remain. What lies beyond the observable universe? Could there be other dimensions, or perhaps even other universes? Are we alone in this vast expanse, or do other forms of life exist in the cosmos? The future of exploration. The future holds exciting possibilities. With next-generation telescopes like the James Webb Space Telescope, we are peering deeper into the cosmos than ever before. Missions to distant planets and moons could reveal new clues about the origins of life. New stars will continue to be born, and new discoveries will push the boundaries of what we know. As we explore the universe, each new answer brings more questions. The mysteries of the universe are far from being solved, and that's what makes the journey so exciting. The universe is an unfathomable expanse of space and time, filled with mysteries that challenge our understanding. For centuries, humanity has gazed at the stars and pondered questions that remain unanswered. The Big Bang. Most scientists agree that the universe began with a monumental event, the Big Bang. Over 13.8 billion years ago, all matter and energy were concentrated in a single point, exploding outward to create everything we see today. But what happened before the Big Bang? What triggered this event? These are questions that push the limits of our understanding. As the universe expanded, it cooled, allowing the formation of stars, galaxies, and planets. Yet, the very origins of time and space remain one of the greatest mysteries. Dark matter and dark energy, the invisible forces. While stars and galaxies make up much of what we can observe, they account for only a fraction of the universe's mass. Scientists discovered that an invisible substance, called dark matter, makes up about 85% of the universe's total mass. This strange, unseen matter holds galaxies together, yet it cannot be seen, touched, or directly detected. And then there's dark energy, an even greater mystery. While dark matter holds galaxies together, dark energy drives them apart, causing the universe to expand at an accelerating rate. We don't know what dark energy is or why it behaves the way it does, but it dominates the universe, making up over 70% of its content. Black holes, the monsters of the cosmos. Black holes are some of the most terrifying and mysterious objects in the universe. These regions of space are so dense that their gravity traps everything, even light. When a massive star collapses under its own gravity, it forms a black hole, a place where the laws of physics break down. At the edge of a black hole, known as the event horizon, time slows down and space warps. But what happens inside a black hole? Could black holes be gateways to other universes, or do they hold the key to understanding the nature of space and time itself? The multiverse theory, are we alone? One of the most intriguing questions in modern science is whether our universe is the only one. Some physicists suggest that we might live in a multiverse, a collection of parallel universes, each with different laws of physics, different dimensions, and perhaps even different versions of ourselves. If the multiverse exists, it could radically change our understanding of reality. Could there be other universes where time flows backward, where stars never form, or where life evolves in ways we can't imagine? The search for extraterrestrial life. Are we alone in the universe? This is one of humanity's oldest questions. With thousands of exoplanets discovered, some within the habitable zone of their stars, the possibility of life beyond Earth seems more plausible than ever. Moons like Europa and Enceladus, which may harbor vast oceans beneath their icy surfaces, offer new frontiers in the search for life. Scientists are probing these worlds, looking for signs of microbial life that might thrive in environments far different from our own. The farthest reaches. What lies beyond the observable universe? The observable universe stretches 93 billion light-years across, but what lies beyond what we can see? Is the universe infinite, or does it have an edge? Could there be regions of space so far away that light has yet to reach us, or are there hidden dimensions that we cannot perceive? Telescopes like the James Webb Space Telescope are peering deeper into space and time than ever before, giving us glimpses of the universe's earliest moments. But the further we look, the more questions arise. The future of exploration, new tools, new discoveries. As technology advances, so does our ability to explore the universe. From gravitational wave detectors to next-generation telescopes, we are entering a golden age of discovery. These tools could help us answer some of the greatest mysteries. How did the universe begin? Are we truly alone? And what is the ultimate fate of the cosmos? Humanity's curiosity drives us to venture beyond our own world, and soon, we may become explorers not only of our solar system but of the stars themselves. The universe is vast, mysterious, and full of unanswered questions. As we uncover its secrets, new mysteries emerge, reminding us that the quest for knowledge is never-ending. The more we explore, the more we realize how much is left to discover. Quantum foam. The universe at the smallest scales. At the smallest scales imaginable, smaller than atoms and even subatomic particles, the universe is thought to be a seething, chaotic mess of quantum foam. This idea comes from quantum mechanics and general relativity and suggests that space-time is not smooth at these scales, but instead consists of tiny, fluctuating energy bubbles. These bubbles pop in and out of existence, possibly giving rise to virtual particles. The structure of space-time itself could be dynamic and unpredictable at these scales, raising profound questions about the nature of reality. The holographic principle. Is the universe a projection? Some physicists, including Stephen Hawking, have proposed the holographic principle, which suggests that the entire 3D universe we experience could be a projection of information stored on a 2D surface, much like a hologram. This idea stems from research on black holes and entropy, where it appears that the information describing a black hole's interior is encoded on its surface. If this principle applies universally, it could mean that what we perceive as the physical world might actually be a kind of projection, raising deep philosophical questions about the nature of existence. The universe's shape. Flat, closed, or open. While most discussions about the universe focus on its expansion, the shape of the universe is a deeper and less understood topic. Cosmologists debate whether the universe is flat, closed, or open. Current data from the cosmic microwave background, CMB, radiation suggests the universe is flat with a very small margin of error. However, the discovery of minute deviations or curvature could reveal a closed universe, like the surface of a sphere, or an open one, like a saddle shape, changing our understanding of cosmology entirely. Antimatter asymmetry. Why does the universe exist? At the moment of the Big Bang, matter and antimatter should have been created in equal amounts. When matter and antimatter come into contact, they annihilate each other, converting into pure energy. Yet, somehow, a tiny excess of matter survived, leading to the creation of galaxies, stars, and everything we see. This imbalance, called baryon asymmetry, remains one of the biggest mysteries in physics. Why the universe is made of matter, and not a featureless soup of energy, is a question still puzzling scientists today. The Great Attractor. A massive, invisible force. While it's well known that galaxies are moving apart due to the expansion of the universe, less commonly discussed is the fact that some galaxies, including our Milky Way, are also moving towards something, an enormous gravitational anomaly known as the Great Attractor. This invisible force is pulling entire galaxy clusters toward it at incredible speeds, around 600 kilometers per second. Despite its vast influence, the exact nature of the Great Attractor remains unclear, as it lies in a region of the sky obscured by our own galaxy, making it hard to observe. Axions. The dark matter candidate you've probably never heard of. While much has been said about dark matter, the mysterious substance that makes up about 85% of the universe's mass, fewer people have heard about one of the leading candidates for what dark matter might be: axions. These hypothetical particles, if they exist, would be incredibly light and weakly interacting, meaning they could explain why dark matter has been so hard to detect. Axions were initially proposed to solve a different problem in quantum chromodynamics, but they have emerged as a potential solution to the dark matter puzzle. Cosmic voids. The universe's great empty spaces. While we tend to think of the universe as full of stars and galaxies, it's actually mostly empty space. In fact, some regions, called cosmic voids, are vast, relatively empty regions that stretch across hundreds of millions of light-years. These voids contain far fewer galaxies than average and are some of the most puzzling features of the universe. They challenge our understanding of how matter clusters together over time, and they could hold clues about the fundamental structure of the cosmos. The cold spot. A possible glitch in the universe or evidence of a parallel universe. One of the most intriguing anomalies in the cosmic microwave background is known as the cold spot. Discovered in 2004, it's a region of space much colder than expected, and it has puzzled cosmologists ever since. Some scientists have speculated that it could be the result of a large supervoid, while others have proposed more exotic explanations, including the possibility that it's evidence of a collision between our universe and a parallel one in a multiverse scenario. If the latter is true, it could be our first observational evidence of other universes. Galactic cannibalism. How galaxies grow. While galaxies may seem like isolated, peaceful structures, they are in fact highly dynamic. Galactic cannibalism refers to the process by which larger galaxies absorb smaller ones. The Milky Way itself is a cannibal, currently in the process of devouring smaller galaxies like the Sagittarius Dwarf Galaxy and the Canis Major Dwarf Galaxy. This merging process plays a key role in galaxy formation and evolution, but it's rarely highlighted in more popular discussions about the cosmos. The cosmological constant problem, a conflict between physics and cosmology. The cosmological constant was introduced by Einstein to describe the energy density of space, later thought of as a mathematical mistake. Today, it's back in the form of dark energy, driving the accelerated expansion of the universe. However, the value of this constant, as predicted by quantum field theory, is off by a staggering factor of 10 to the power of 120 from what we observe, a mismatch so large that it's often considered the biggest crisis in theoretical physics. The fact that we don't understand why the cosmological constant has the value it does could point to a profound gap in our understanding of physics. Primordial black holes. Possible dark matter candidates. Primordial black holes, PBHs, are hypothetical black holes that might have formed shortly after the Big Bang, before stars and galaxies existed. Unlike black holes formed from collapsing stars, primordial black holes could have originated from extreme density fluctuations in the early universe. These black holes could range from tiny, subatomic-sized objects to massive ones comparable to the mass of a planet. Interestingly, some scientists believe that these primordial black holes could be candidates for dark matter, which remains one of the biggest unsolved mysteries in cosmology. Dark matter doesn't emit light or energy, but its gravitational effects are observable throughout the universe. If primordial black holes make up a portion of dark matter, it could solve part of this mystery, but finding evidence for their existence is a significant challenge. Cosmic strings. Defects in spacetime. Cosmic strings are theoretical one-dimensional defects in the fabric of spacetime that may have formed during phase transitions in the early universe, somewhat analogous to cracks that form in ice as water freezes. These cosmic strings could stretch across vast distances in space, possibly even spanning galaxies. They're incredibly thin but could contain enormous amounts of energy, with densities so high that they might warp space-time around them, creating gravitational waves. If cosmic strings exist, they might offer insights into the structure of the universe at its most fundamental level and help scientists understand the physics of the early universe, including phenomena like inflation, the rapid expansion of the universe right after the Big Bang. Boltzmann brains, the philosophical universe paradox. The concept of Boltzmann brains is one of the most mind-bending philosophical paradoxes in cosmology. Named after the physicist Ludwig Boltzmann, this idea is rooted in thermodynamics and statistical mechanics. In a universe that exists for an infinite amount of time, it's statistically possible that random fluctuations in entropy could produce self-aware entities, disembodied brains with memories and consciousness, that spontaneously form in the vacuum of space. The paradox challenges our understanding of the universe's structure because, theoretically, there could be vastly more Boltzmann brains than actual human brains. It raises questions about the nature of reality. How do we know we're not Boltzmann brains ourselves, existing as momentary blips of consciousness in an otherwise empty universe? The anthropic principle. Why does the universe seem fine-tuned for life? The anthropic principle suggests that the universe's fundamental constants, such as the strength of gravity, the electromagnetic force, and the properties of elementary particles, are finely tuned to allow the existence of life. If any of these constants were slightly different, stars, planets, and even atoms wouldn't form, and life as we know it wouldn't exist. There are two main versions of the anthropic principle. The weak anthropic principle. This version argues that we observe the universe to be suitable for life because we are here to observe it. In other words, the universe must have these properties for life to exist, so it's no surprise that it does. The strong anthropic principle. This more speculative idea suggests that the universe is designed in some way to support life, or that multiple universes exist, a multiverse, and we happen to live in one of the few that can support life. The anthropic principle leads to deep philosophical and scientific debates about why the universe seems to be so perfectly calibrated for the emergence of life. Vacuum decay. The universe could collapse at any moment. One of the more unsettling, but fascinating, possibilities in theoretical physics is the idea of vacuum decay. According to our current understanding, the universe might not be in a true vacuum, the most stable state it could be in, but rather a false vacuum, a temporary state that appears stable but could eventually collapse into a more stable state. If vacuum decay were to occur, a bubble of true vacuum could form somewhere in the universe and expand at nearly the speed of light, destroying everything in its path. This is called a vacuum metastability event. Since this bubble would move faster than light, we wouldn't see it coming, and it would wipe out the laws of physics as we know them. The idea stems from quantum field theory, particularly related to the Higgs field, which gives particles their mass. While vacuum decay is a remote possibility, it illustrates how fragile and transient our universe's current state might be. The heat death of the universe, the ultimate fate. While discussions about the expansion of the universe and dark energy are common, fewer people talk about what might happen to the universe in the very distant future. The heat death, or Big Freeze, is a theoretical scenario for the ultimate fate of the universe. In this scenario, as the universe continues to expand and dark energy drives galaxies further apart, it will reach a state where all usable energy has been expended. At this point, stars will burn out, black holes will evaporate, and even matter itself could break down into subatomic particles. The universe would become a cold, dark, lifeless place, with no energy left to fuel processes that sustain life. This idea is based on the second law of thermodynamics, which states that entropy, disorder, always increases over time in a closed system. Planck stars. A possible alternative to black holes. Planck stars are a hypothetical concept that offers an alternative to the classical idea of black holes. According to general relativity, once a star collapses into a black hole, it becomes a singularity, a point where gravity is so intense that space and time cease to exist as we understand them. However, in quantum gravity models, such as loop quantum gravity, it's possible that before a black hole reaches the singularity stage, quantum effects could cause a bounce, creating what's known as a Planck star. This theory suggests that instead of matter being crushed into an infinitely dense point, it could reach a point of maximum compression and then begin to expand again. Planck stars could provide an explanation for black holes that avoid the paradoxes of singularities, and some theories even suggest that these objects could explode in massive bursts of energy after long periods of time, releasing the information they swallowed. Cosmic neutrino background, the ghosts of the Big Bang. While the cosmic microwave background, CMB, is well known as the afterglow of the Big Bang, another relic from the universe's early moments is the cosmic neutrino background, CNB. These are primordial neutrinos, extremely light and weakly interacting particles, produced just seconds after the Big Bang. Unlike photons from the CMB, which we can observe directly, neutrinos are notoriously difficult to detect because they rarely interact with matter. The CNB, if fully understood, could offer crucial insights into the very first moments of the universe, shedding light on processes that occurred long before the universe became transparent to radiation. Galactic rotation curves. Evidence of dark matter. One of the early clues to the existence of dark matter came from the study of galactic rotation curves. When scientists measured the rotational speeds of stars in galaxies, they found that stars on the outskirts of galaxies were moving much faster than they should be, given the visible matter in those galaxies. According to Newtonian mechanics, these stars should have been flung off by centrifugal force, but something was holding them in place. The best explanation is that there's an unseen mass, dark matter, exerting a gravitational pull on the stars, keeping them in orbit around the galaxy's center. This phenomenon is still one of the strongest pieces of evidence for dark matter, even though we've yet to detect it directly. The mysteries of the universe are vast and ever-expanding, with so much left for us to explore and discover. From the strange quantum world to the cosmic wonders, our journey is only just beginning. If you enjoy diving into these mind-bending topics, don't forget to hit that like button and subscribe to stay updated on more amazing content. And if there's a mystery of the universe you'd like to learn more about, drop a comment below. I'd love to hear your thoughts and ideas. Thanks for watching, and let's keep exploring the cosmos together.